Best options for using AI in chip design. Narrowly defined verticals offer the best opportunity for AI, plus what will the impact be on a junior engineers. Experts at the table. Semiconductor engineering sat down to discuss how and where AI can be applied to chip design to maximize its value and how that will impact the design process with the chalk output. Kenneth Fellow, Satish Balasubramanian, head of product marketing and engineering director for customized C at Gmail CDA, Anand Tiruvengadam, Senior Director and Head of AI Product Management at Synopsys. Sailesh Kumar, CEO of Baya Systems. Mehir Arora, Head of Engineering at Chip Agent. Darren McClellan, Product Manager at Keysight. What follows the excerpt of the conversion to view part of 1. Click here. At Keysight, let's see. Does AI fundamentally change chip design? In the past, designs were broadly domain specific, but in the future, can you have domains and subdomains as opposed to the large domains and to one large domains? The Balasubramanian, yes, that's a big change. For each of the verticals, there are certain criteria that are important, like automotive or mission-critical applications. And high-performance computing, no one used to care. We used to talk about low power, but 5 years ago, no one was talking about low power anymore. Just look at NVIDIA's racks and their power consumption. It's all speed. Each vertical has its own requirement, and that drives what kind of technology or product or solutions we need to provide to our customers. Kumar, CAD tools can benefit a lot from AI. As you build these models, you automate a lot of things based on data. That's where you can build vertical solutions because each vertical's design patterns are different, so you can have a highly focused AI. Arpit, I'll look at the technology and ask, what can we build with the LLMs today? What do we think we can deliver in 3 months or 6 months? Obviously, you want to collect the low-hanging fruit like debug analysis. You can generate scripts to say, what is wrong with my design? How can I fix it? Give it a suggestion. In automotive, we all have a lane assist now, and you back up and something is behind you. It goes beep, beep. It does fundamentally change the way you drive. Maybe you don't twist your neck as much because you're looking at the camera, but you're still driving the car. And you can see that self-driving cars are coming. If you have a kid today, you might not ever need to teach them to drive. So there are these short-term things that will make designers more productive, and there are these longer-term things like self-driving cars that will really be disruptive. Balasubramanian, we have a Wave 360 digital twin for automotive. You can run your RTL on an emulator or on an FPGA for prototyping. You can run your software, you can build in your road and traffic scenarios, and you can use the synthetic data to model the way the whole car behaves. And then we can connect the rear car on a test track. That's a digital twin. EDA has been doing this for a time. we are getting into a higher and higher abstraction. Tiruvengam, this steady state, through autonomous workflows, is gonna be truly disruptive. We are quite away from that, away from that, but our genetic vision involves increasing levels of autonomy. We essentially have rolled out L1 through L5, where L5 is the holy grail with their fully autonomous end-to-end workflows. L1 is where we are today and maybe heading into L2. L3 involves orchestration and the planning and the decision making. When we get to L5, we'll be asking questions like, are junior level engineers really needed? That's when those questions become pertinent, but not right now. Aurora, we can twist this whole discussion on its head. Up until now, we've been talking about EDA tools for humans, but we can start to talk about EDA tools for agents. These agents are trained on natural language, and that's what the pre-training is. But we can actually build better tooling for agents. The interesting new things about the agentic system is that there are only a couple of ways in which LLMs are superior to humans. One of them is that they have a patient than your average human, and they read a lot faster. And so from their perspective, you can start to think about developing EDA tooling where you are more interested in the parallelism. You're interested in trying more things more aggressively as opposed to a human who is kind of single-threaded. So in some sense, we can talk about slapping AI on the topic of existing tooling, but we also have to think about the fact that at some point we are gonna have agentic platforms. What tools are those platforms gonna end up using? This is gonna be a serious domain because there are big differences in the way humans use these ED tools and the agent to use this tool. Output. We're already there. We have tools that have been built on the top of tools, and these tools have been modified for that purpose. These homologation AI tools are part of our journey, and we are connect those into bigger agentic workflows. Tiruvekadam. We look at this in the term of value tiers. The optimization is one value tiers for AI, and that's already been tested for many years. And we have optimization engines across multiple verticals with the EDA flow. So for example, test analog digital implementation or verification. Then there's another value tier is terms of analytics. These are important because they are the foundation for the next value tier, which is generative AI and agentic AI. Agentic eventually will leverage tool and also some of the other engines to orchestration a full flow. It's not just a tool. We think in terms of value hierarchy. McLennan. One of the things we are seeing is the application people in verticals are pulling forward the server-specific problems. One of those problems is radio-oriented propagation of data, other kinds of materials and things that serve real use cases. These are more than just EDA. There is synthesis of other kinds of measurements and observation. So the idea of the agent may be in a customer organization, driving some of our pits to solve their tasks. Also, something we are beginning to see is people owning their own data and machine learning to drive specific applications. A senior engineering using AI can spot something that is way off base and recognize that a tool have messed up and it needs to be reconfigured. Young engineers don't necessarily have history to recognize that. How do we ensure that we don't have these kind of obvious errors? Balasubramanian. It depends on what stage it's in it. What we are trying to do is give as much information as possible where we are very confident in the answer for the engineer. For example, maybe someone is doing a place in route block and there is a global route with a huge congestion and that they are pushing through the flow and learning multiple thousands of scenarios. So there are a lot of different recipes but there is intelligence you can build in building intelligence you can build in that can prevent engineers from going in a wrong direction. If you have a centralized EDA AI system that's driving these flows, when you hit a certain heuristic in your design, you actually have to give feedback, either good or bad, to an engineer. Hey, you don't need to proceed further, or I know you're on the wrong track. It doesn't matter if it is junior and senior engineer. It's a matter of how much we can learn from what we have done before. Repeat, that's not a new problem. We've seen building engineering teams in other geographies with lots of inexperienced people, and they run. Having young talent is really important. As we all age, companies become stuck in doing things the same way. You have to bring in new people to be disruptive to it, and that's a good thing. Just like customers build flows and write scripts to get their own secret sauce. I see them building their own agent on top of our infrastructure. We provide tools, and if we have custom protocols like MCP, Model Context Protocol, maybe they won't be doing scripts anymore. They will be building agents specifically for their design tasks and their work with our tools and APIs. I can foresee a world where the skill merges and young engineers will probably be good at that. Tiruvegadam. We are being too quick to jump into an agentic discussion. There are many steps to it. There are generative AI capabilities even before we get to agent. There's a whole bunch of assistance we can provide to young engineers. Essay. It's moving a lot faster than in the past, though. Tiruvengadam. Yes, it's evolving really fast, but you still cannot skip these critical steps. For example, there is a knowledge assistance that will greatly benefit a junior engineer compared to an expert. The assistance that you can provide a junior or middle level of engineers when it comes to script generation. Let's be at the next steps when you look at a log file. These are all things that are available today. These are the foundation of the agent. McLaren. If you look at the sports and kids coming out of minor leagues and colleges, they are hitting their peak not at 27 or 28 but 23. Part of it is coaching and specific feedback on how they can improve. For engineers, the ability to dream bigger, get feedback, and accomplish to fail faster is accelerated learning. Even for humans, when it was less mature, there was a resistance. You're not going to use a calculator anymore. It's part of how you learn. Aurora, that's an excellent point. What we are circling around is the question of legibility. How do you make these tools legible to people? On one hand, we're really talking about pushing humans up to the level of the AI systems, which are a bit hard to understand because they are doing so much for you in an autonomous way. But we also can push down. We can start with the AI systems, and we can try to make them to more legible to humans. A fundamentally problem that is gonna be attempted to solve at the rich levels, at the product level by multiple businesses. As how do we make an AI proof of the work legible to people? When an engineer comes to you and they will deliver something to you, and you are an engineer and you understand all the same jargon, they can effectively describe to you in very quick terms, some of them short, and form proof that a work they've achieved ticks all the boxes that you're interested in. I'm not necessarily talking about a formal proof, but something that is sufficient for another human being to understand. Yes, that work that I actually checked all the boxes. I dotted all these I's across. That is this. Can AI systems do the same things? Can we make the review of the all AI itself on a task that optimized for? Because as they start to do more, it's gonna become even more indecipherable. It's gonna be a very hard. So we have to bring this down into a way where humans are gonna be able to put in the position to review this work more efficiently and effectively. Well, you don't necessarily have to look at everything in the pain, skating details and the drive everything yourself. Kumar, hopefully, AI can bring a higher level of abstraction. The way we scale is by abstraction. We used to design chips at much lower levels of abstraction. Now we design a higher level of the abstraction. We are in the IP paradigm, where we design chips from IPs, and we are getting to the chiplet paradigm. If AI can help make the design abstraction higher, then we'll accelerate the learning of our junior engineers. At Baya, we do on-chip factory fabrics, and I started with a couple of dozen engineers with 20 plus years of experience. Now we are bringing new talent. I'm always amazing at what they do, what they can do. They come right out of college, and within 6 months they become very productive. They put in 80 hours a week. They are absolutely mind-blowing. So we have to find every possible way to bring in the new talent and make sure that we scale our capacity and leverage them in the best possible way. If AI can help with that by creating new abstraction levels, making the tools easier to use, to leverage the whole knowledge base effectively, they can lower the bar and bring all these junior engineers into mainstream. Okay, I read this article, best options for using AI in chip design. Thank you for your time. See you next time.